Hello and welcome to this overview of the IBM 3101 ASCII Display Station.
A couple of disclaimers before the scheduled programming starts. 1. This video is not sponsored nor is affiliated with any companies, organizations or similar groups mentioned in this video. 2. The product is no longer in production and thus commercially unavailable to purchase. 3. This video is not an endorsement or an advertisement of the mentioned product. 4. Any opinions made about this product is solely expressed by the authors of this video. 5. The information presented in this video is provided as is. There is no guarantee that the information is accurate or complete. With those disclaimers aside, the scheduled programming will begin.
So what do we have here today? Today we will be looking at an IBM 3101, a line of terminal computers that were used with a wide variety of IBM and non-IBM made computers. Produced by IBM, the IBM 3101 was first released in 1979. It had a price tag of up to $1520 in 1979 USDs, or around $6,600 adjusted for 2024 inflation. It comes in 6 models, a character model and a block model, each with a choice of 3 interface options.
This specific terminal we are looking today is loaned to us by the owner, who claims that they bought the terminal over an online transaction for an undisclosed sum. However, this keyboard was bought separately from the package and was obtained through an estate sale that the owner is unwilling to disclose. After some negotiations and logistics, this arrived at our PO box, so let's see what we've got.
We've got a CRT monitor which also comes with a glare filter, the logic unit which also doubles as the monitor's angle adjustments, and the 2 keyboards. So the CRT monitor houses a 12-inch screen that has a resolution of 24 lines with 80 characters each, and a 25th line to display info to the user. It also comes with a detachable glare filter to reduce glare from surrounding lights.
This is the logic unit, which houses most of the terminal's brains. It also has these tracks on top that enables the monitor to be adjusted. This allows for a 12.5 degree swivel and either a 10 degree or a 15 degree vertical tilt. On the back has 4 ports, 1 for the monitor, 1 for connection to an auxiliary device, 1 to a compatible computer and 1 for the keyboard. It also has a fuse to prevent overcurrent from damaging the terminal. The logic unit has a built-in diagnostics program, can be activated by switching this blue switch to test. Once flipped, the diagnostics program will take a moment to find any issues. If there are issues found, it will display the issue that it finds, like this example. If the diagnostics found no errors, it will display this screen. This screen also functions as a keyboard tester to make sure all keys work like so.
This is the keyboard, probably the most attention-grabbing unit out of the terminal. These keyboards have a reputation of durable construction, a proprietary clicky key switch, and despite the age, it can be converted to be used in modern systems. The other keyboard, while cheaper, also enjoys a similar reputation. Most people would probably know this keyboard as either the Beam Spring keyboards due to its proprietary switches, or the Model B, based on IBM's internal designation. However, what most people wouldn't know is that this keyboard is actually called the keyboard E. But there doesn't seem to be any difference between the B and the E, so whatever. The alternative keyboard option is the more ergonomic keyboard F. While the keyboard F was made as a response to EU regulations, it is equally likely that these keyboards were made due to the cheapening of computers. Even if the keyboard F was a cheaper product, it's still a high-quality product, using buckling springs, which are still a very well-known clicky key switch. Both keyboards do have similar features, so let's check them out. Both keyboards have a strange layout, which stems from the typewriter with numpad layout. Although on the keyboard F, there are no separator panels between each cluster, both keyboards have a slot to store some documentation. For the keyboard E, there is a swing-out tray located under the keyboard, although the tray was broken at some point but was fixed. For the keyboard F, it is just a slot instead of the tray, in order to reduce the height of the keyboard. The tray or slot hold documentation such as a reference brochure or the 3101 troubleshooting guide. On the booklet, this is essentially a troubleshooting guide for the user to fix any issues they may encounter by themselves. On the brochure, this is a reference manual that shows various information from ASCII control characters to what each switch does, and a set of blank switches templates for the user to mark down what they set for their terminal. However, this is where some of the features will differ. First and most noticeable is the construction, where the keyboard E is made of an all-metal case. Meanwhile, the keyboard F is made of durable plastics. As some persons may notice, some of the key legends are different from each other. That is because the keyboard F is actually for the IBM 7485, a custom factory-requested modification of the 3101. This version is offered for customers who have a specific configuration in mind, so they don't need to do the configuration themselves. That means another difference between these two keyboards is what's under this compartment. On the keyboard E, there is a bank of dip switches that the user can configure to the computer it's attached to, and a helpful label for each switch. On the keyboard F, there is nothing there except for the keyboard foam, where the dip switches would be. But if the keyboard F was made for the 3101, then most likely the switches would be here. In addition, the keyboard E possesses a solenoid that triggers upon most key presses, which this keyboard F does not. Let's have a typing demonstration to hear how each keyboard sounds like. However, the keyboard E will have two demonstrations, one with the solenoid on and one for it off.
So most of you would want to see this in action. The problem is, we don't have any computers to test the 3101 with. Even with the 3101's ability to be used with third-party machines, those are basically ancient pieces of shite that are hard to obtain. So instead of scouring across the world for such a computer, the owner did some research and found out that it is possible to hook the 3101 to a modern computer as a serial device. So, as mentioned before, the IBM 3101 is able to connect to non-IBM computers. When we said non-IBM computers, it also includes modern-day computers through a serial connection.
But it's so old, how is that even possible?
With the help of the camera operator. Let us set that up and show you how both the camera operator and the owner configured this machine to work with modern computers. Okay, looks like it's set up. Let's see what they came up with. So what we have here is this mess of adapters, a mini computer that will act as our host machine, and that's basically it. The main star of the show is the use of this full null modem, which allows the terminal to talk to other computers without the need for a dedicated modem unit. Once a full modem is acquired, use any combination of adapters to connect to your machine, in our case USB. But we are not done yet. We need to set up the dip switches, so it works with the computer it's attached to. This is the combination of dip switches that we used, that works with our setup. Now we are finished for the hardware, but we need to deal with the software side. For this example, this mini computer uses Arch Linux.
BT dubs.
Shilling aside, by default using Arch install. Arch Linux already has the IBE 101 terminfo installed. But almost any Linux distro should work, assuming the following files exist at the following locations. If not, there should be guides online to compile a working 3101 terminfo. Afterwards, input this command to spawn a agetty instance. Do these commands just in case. Now copy a generic serial-getty .service file and name the copy of the spawned instance. In our case, it's tty-usb0.service. Open the service file with your favorite text editor. At this point, serial-getty at tty-usb0.service needs to be configured. This is what the owner and the camera operator came up with. All the commands and the file contents will be pasted in the description below. Once this is finished, restart the service using systemctl, and hopefully everything works. After waiting for a bit, turn on the terminal login. And now we have a hardware console, with some rendering errors as the 3101 only renders ASCII characters.
For those who are into rising, here is the fast fetch output. However, since the terminal resolution is smaller than the output, some of the output may display incorrectly. So let's go over a few things concerning the keyboard when connected to a Linux machine. These two pictures will show each scan code and/or command combinations that the terminal will output to Linux. For example, pressing the A button will output a lowercase a, but pressing Alt plus A outputs SOH, which is Control A for putting the cursor at the start of the line. So for all intents and purposes, the Alt key is the Control key. So let's look at the other keys. The solenoid toggle works as intended. What looks like the caps lock is actually a shift lock. To disengage it, simply press either shift keys. The following keys and key combinations will lock up the terminal. In order to unlock it, Press the reset key, so don't press those keys or key combinations unless you want a primitive keyboard lock. But aside from those differences, it is basically a Linux terminal with less modifiers. So the biggest question most of you probably have in mind: can this game? Well, to its credit, it can play text-based games such as Nethak. But since the mini computer we are using is so weak, we weren't able to load other games. So what else can you do with it? Well, anything you can do on the terminal, you can do over this ancient technology, such as use top to monitor the system, use Pacman to update the computer, browse the web using a text-based web browser, grab a screensaver because this is a CRT monitor, and the monitor already has some burn-in from when it was used for inventory management. And anything else you would do on a terminal. Now that we showed that this terminal is basically a hardware Linux terminal instance, we still have one more experiment. What happens when we try to use the keyboard F? Unfortunately, this keyboard appears to be pre-programmed to use a specific dip switch settings, which we found out that it doesn't play nice with Linux. Thank you for watching. We hope you enjoyed this video and have a nice day.